Ladies and gentlemen, I need quiet, please.
Nice.
All right, for those of you that are distance learning, I just want to let you know that we are moving the homework to Monday. Okay. Now, with that said, okay,
No, we can't do that.
I would
Right, yeah.
seriously, I would go through some of these links that I shared with you. This one in particular, it's a reaction review, and it'll give you a reaction, and it'll test your knowledge about what the reactants are. Okay, I would definitely try that.
Can you use it on a computer or an iPad?
You might have to use a computer.
Do
I
you use
don't
a
know.
Mac or do you need?
It might be Flash. Okay.
Yeah.
The other thing is that there's a tutorial on alkene, alkyne. Okay, you might want to go through that. And then there's the ACE the test review. But I don't ask everything that the test has. Okay, so just to let you know.
Wait,
All right.
when is this test?
So if homework is on Monday, test is on Tuesday.
Okay.
Okay. All right. Now for the next 5 to 10 minutes, I will take homework questions.
Okay, like 51 and then everything after that.
All right. 51. Okay, 51 is Diels Alder. Can I answer that in a little bit?
Yes.
Yeah.
Okay, I'd rather answer the ones that we've already gone over, the reactions we've gone over. Okay, what next?
Oh wait, I have a question about.
So like for, what about like 52?
52 is Diels Alder.
Oh, okay.
For
Okay.
53, I just drew the structure, but I didn't give it an equation. So it's well, because it was easier for me to just draw where the bonds are.
Yeah,
broken.
yeah, that's fine.
Because it asked for an equation, but I found it easier to just, I put, because this is an anti for contact.
Yeah, that's anti.
It is?
Yeah.
So I would just look at where the number of bonding carbons are,
Uh-huh.
and then change it, and then just.
Uh-huh.
use that.
Uh-huh.
Okay.
Oh, that looks good. Yeah, yeah. All right, anybody else?
For 34A,
34A.
do you have to put one propene to show who the double bond is? Or can you just put
34A.
propene?
Free propyl.
It should be 3-propyl,
2-hexene.
2-hexene. 3-propyl, 2-hexene.
Okay, so you can split up those, cause you wanna have like the longest chain.
Yeah, and it has to
Okay.
include the double bond. Okay, so that's
I
why
was-
it's hexene.
I thought, cause it had the CH2, CH2, CH3 in parentheses
How do you do
and had it
53?
doubled.
Yes.
I was thinking that was a substituent then off that last carbon.
Okay, so the way,
Cause then that would give that carbon
So
4 bonds, that's what I was confused about.
okay, so the way I drew it is I drew it this way.
I drew a substituent.
2-hexene.
Two, I think.
Oh, okay, I just didn't have the
Oh.
chain then.
Okay, and then, who asked this question? Was it Ellie?
Yeah.
Yes.
Okay, you wanna count this as the longest chain, or
Yeah.
you could go up, you don't have to,
Okay.
it doesn't matter, cause they're both the same length, okay? Alright, so that would be, 2-hexene, but you
Yeah.
wanna list the substituent
Same list.
first, okay? Alright, anybody else?
Can you like give it, can we do it like 53A together just so I?
Can I, oh, you want 53A?
Yeah, 53A.
Oh, yeah,
Just like
I could do
so I
53A,
can
okay.
figure out how to do the rest.
So Jeremy, this is gonna show up on the video?
Yeah, we're good.
Okay, alright, so here is a, 1, 2, 3, 4, butene, okay? And I know Irene was asking, why is there a 1 and then there's a 2? I'm not showing
The
the
boron.
first step, okay? So boron attaches itself to this molecule, and actually there's 2 other parts that I'm not showing, okay? I'm going straight to the product. And notice that this is sort of a catalyst, and this is the actual group that attaches to the final product. That's it.
So you're just removing the double bond and then placing that.
So there's a hydrogen that attaches from that BH3, and then at the end, the OH attaches on the end. And this is an anti-Markovnikov.
Okay, I'm confused as to where like the
If it was marked,
BH3 and everything like comes on.
I'm not showing that step. I am just showing the final product, okay?
It's like
Now,
the-
if it was
the
marked-
H2O2 is like a catalyst, so
Yeah.
it doesn't stay.
Yeah, it doesn't attach to the final product. The only thing that attaches is this OH here, okay?
And so you just add it where the
And
double
you're
bond
doing-
was?
So anti-Markovnikovs, you put them where they're
More
least.
hydrogen.
Oh,
So,
Thought that was.
remember,
I thought
Markovnikov, the electrophile attaches to carbon with the most hydrogen,
Most.
okay? So, technically, if you followed Markovnikov, the OH would be on the second carbon,
Yeah.
but it's on the end,
Okay.
okay? So,
It wants to be on the least
you know, did I
bonded
draw that
carbon.
right? Alright, cause this would be carbon one, I'm missing a, cause this would be carbon one, well, I need another, this is carbon two, this is carbon three, this is carbon four, right?
Yeah.
I didn't draw that very well, sorry. Okay, so Markovnikov, that OH would be on the second carbon, but because this is anti-Markovnikov, this is on the first carbon.
So Markovnikov, you put,
The electrophile goes to the carbon in the double bond that has the most hydrogen, okay?
So the most bonded carbon.
So if this followed Markovnikov's rule, we should have
It'd be on the number.
it on here, okay, and we should have OH here. But instead we have OH here and we have, hydrogen there.
Can we do one of the cyclos?
For 53?
Yeah, like B.
Yeah, we could do that. Okay, I'll do B. So B,
OH.
okay, we have cyclopentene. And it's got two methyl groups on either end. Okay, now the way this adds, it doesn't matter, well, it does matter what side you pick, okay? You don't wanna pick the side without the double bond, okay? So there's gonna be a methyl group here, cause there's no double bond by it, okay? So it has to be on this side. So if it followed Markovnikov's rule, we would have the OH over here. Does that make sense?
Yes.
because it wants to go on the second carbon.
But this has the least amount of hydrogen, right? Do you agree? This has more hydrogen than this side on the double bond?
Yeah, because there's more bonds in the upper one, correct? So that.
Oh, so
less
there would be
hydrogen.
This is a methyl group, right? So
Yeah,
this
so
one
they-
has the least
We're
number of
gonna only have
hydrogen,
one
right?
hydrogen, the other one have two.
So if it followed Markovnikov's rule, the H would go here and the OH would go there. But that's not the case. It's anti-Markovnikov. So you have a methyl group there and you have an OH over here. Okay? And if you want to pay attention to stereochemistry, this is coming out of the page and this is going behind, okay?
Can we go over like just the Markovnikov and anti-Markovnikov? 'Cause I'm like so confused about that.
Sure.
I thought it was going on like
Sure.
the first and
All right,
second carbon.
you
but,
ready?
like, now we're talking about hydrogen.
Let's do it.
The most and the least.
Let's do it. in order that we do it.
So the most hydrogen and the least hydrogen.
Okay, so the one that we have, do you wanna do, just hydration? Where it follows Markovnikov?
Yeah.
So we have water and acid. Alright, I have to erase this, is that alright?
Mm-hmm.
Okay, so for this one, we're adding water, right? What would be the electrophile in water?
The hydrogen.
The hydrogen, right? Okay, so it's gonna add where? Across the double bond?
On
CH2, right?
Yep.
Cause we want a
Yeah.
carbocation here, right?
Yeah.
Do I have to draw the intermediate?
Yeah.
be helpful?
Yes. Big time. So you're adding one to the.
You're
to
adding a
You're adding
hydrogen
one
here.
to the. You're adding one to the end and one to the middle carbon to make it a carbocation.
So this is an intermediate, right?
Yeah.
And you're gonna add OH minus, and then you should get,
So like, where's the
Hold
oxygen?
on.
Oh, okay.
Big time.
okay, that is Markovnikov's rule.
Okay, so how do you determine again where each one goes? Like why each hydrogen
So
goes? somewhere?
hydrogen is going to add across the double bond where it has the most hydrogen. This carbon across the double
Has more
bond has the
hydrogen.
most hydrogen, okay? Alright, I am not showing the intermediate step for this, because this is multi-step. I will
Yeah.
show you the product, okay? 'Cause
Okay.
I don't want you to get overly bogged down with stuff, okay? Okay, do you see the difference?
Wait a second here.
So the top one is Markovnikov, the bottom is anti-Markovnikov.
CH2.
Do I have too many hydrogen? No. Alright.
So the top, you attach it to the one on the double bond with the least hydrogens.
Yes.
And the bottom, you're attaching with the most hydrogens from the double bond.
Yeah,
Good stuff.
yeah.
So Markovnikov is least.
And then you give the hydrogen to the other one on the other side
Wait,
of
I
the double bond.
thought Markovnikov was most
We are here.
hydrogens.
Yeah, yeah.
Okay, and then
So-
anti-Markovnikov is you're attaching it to one of the least.
Cause the hydrogen gets added to the one with the most hydrogens, but the electrophile,
Where?
nucleophile,
Nucleophile.
gets added to the one with the least hydrogens.
Yeah, so
And it just flips an
Ellie,
anti.
just write down Markovnikov, the electrophile is being added to the carbon across the double bond that has the least number of hydrogen. This is the nucleophile, not
Oh,
the
so the
electrophile.
OH is the nucleophile.
The OH is the nucleophile.
And you're adding that to the one with the least hydrogen.
Okay, this is the nucleophile. It is adding to the carbon with the least number of hydrogen, but it's adding it to the one with the most. Yep. Yep.
Dang.
That makes sense.
Okay, alright. I really need to move on, people, so if you have any additional questions, can you find me? And I will sit down with you and work on these things.
Yes.
Alright, the next thing I wanna talk about is, conjugated dienes. Conjugated dienes, all it means is that you have two or more double bonds and they are not together, they're alternating, okay? And you might say, what is that? Let me show you an example of that. Okay, here is conjugated dienes. This is number 74 in your notes. So conjugated dienes, they have a double bond, a space, and then they have another double bond. Okay, so they have alternating double bonds. And the interesting thing is you get two different products because of resonance. So conjugated dienes, you get two different products because of resonance. So you could get addition on the one side or you could get addition on the other side. Okay, and I'll give you some examples here. Okay, so this is conjugated diene. Can I erase this?
Yes.
Okay. So the example I'm gonna show you is hexadiene. Okay, my question to you is, I only have one HBr, 1 mole, okay? I'm not doubling the amount. If I was doubling the amount, the HBr would add across both double bonds. Okay, so I'm just adding it across one double bond, okay? So the question is, what would be the easiest place to put the HBr? here? Where do you wanna put the bromine?
Like, you're gonna wanna put it with the least hydrogen, or no, the most.
Well, bromine is what? Is it the electrophile or nucleophile?
Nucleophile.
It's the nucleophile,
So one with
right?
least- So one with the least hydrogen across the double bond, so you have two double
CH.
bonds. Doesn't matter, it's just this will have resonance, so it doesn't
This
matter.
is resonance,
Yeah,
yeah.
so you pick either one.
So, I would probably pick this one to put the nucleophile.
Could you also put it on the next CH?
You could also put it potentially over
Yeah,
here.
yeah,
It's
but
symmetrical.
with resonance it's the same.
It's symmetrical.
Yep.
Okay, so I said. Okay, I said that's one of the products.
Okay.
Okay?
Yep.
So I said that is one of the products. Now, the interesting thing is, with resonance, we can have the double bond moving around, okay? So we could have the double bond moving around.
Bully.
Yeah, I know, just to make it interesting, okay? So, do you agree this would be, close to 1,2 addition? Okay, no, it's not the same molecule, but you would argue it's close to 1,2 addition? Yeah. Alright, well, I don't have resonance here. Okay, if you turn in your book, I would just write this down, because I don't have a slide for it, unfortunately. If you turn to page 93, okay, so I would look at page 93. They show you resonance that takes place when you have a conjugated diene, okay? So the double bond could actually move around. All right, so let me show you an example of this. So we could go this way where we get a carbocation forming.
What? 55, 54, 55.
So here we just have the addition of hydrogen, okay? And we have a carbocation forming. So as a result, we can move things around, okay? We can move that double bond over to here. And then this becomes a carbocation. That should be a CH2 there.
Does combustion produce a color change? In the flame, yeah. This is Vrobel.
Yeah.
Does combustion produce a color change? Could it show a color change in comparison to two different compounds?
Oh, yeah,
Yes?
yeah, the flame.
Cool,
Yeah,
Good,
yeah.
good.
Where'd the double bond go?
Oh, I'm sorry.
Boom.
I apologize.
Business.
I'm moving a mile a minute. How's that? Is that better?
Oh.
Okay, so notice that the double bond moved to the middle, and then the question is, where do you put the bromine? So the bromine would go where that carbocation is, okay? So our second product would be this.
Alright.
Yeah. So does everybody see how the double bond could rearrange, and we get a double bond in the middle with the bromine?
So you're just switching the double bond and the bromine.
Literally, yeah. it's all
So you're moving it around, yeah, that's all you're doing.
resonance.
Okay, yes, yes.
How is it going, Jeremy? Hi, Wagner.
He's like, who are you talking to? Okay, how are we doing here? Alright. Okay, so that's conjugated dienes, okay? Does anybody have any questions about that? Lance?
Is the product there, is that drawn for the, both of, is that drawn for both of those or the one on the
So
right?
we could get this product and we can get this product, so there's two.
I'm saying, is that the product of that whole giant thing in brackets?
Well, this is because of resonance.
Okay.
So we get that
So can both
product-
of those resonance
So-
structures have that same product?
Yeah, so remember resonance, oh, by the way, any AP people,
What?
okay?
What?
Resonance, okay, it happens so fast that you could almost draw like a dotted line to show a pseudo bond, okay? But yeah, because of this moving back and forth, it ends up forming this product. Okay, so these are the two products, okay?
Okay.
Alright, anybody else before I
Is
move
that
on?
only with conjugated dienes?
Conjugated dienes.
Okay, and then how do we make like the discrepancy that it is a conjugated diene?
So it has to have alternating double bonds, so there has to be
So
at
there's
least
always gonna be
two.
Two sets, or there's
And
two
there'll be
sets of
two-
double bonds, and they'll be symmetrical in this position, like spots in them.
Not,
You know what I mean, Lance?
yeah, like he's saying that like, you would be able to like change where the cation is.
Yeah,
or
yeah,
the
you can change where the
carbocation.
cation is, yeah, yeah,
Good stuff.
okay.
Yep.
Anybody else? Alright, here is your question about Diels Alder. Can I erase this?
Yes.
Please do.
Alright. By the way, I would go to, slide 77, cause this is a great picture of how to arrange your molecule using Diels Alder, okay? You need to have a diene, so everybody see how there's a diene here? So there's two double bonds, and then you need a dienophile. What do you think a dienophile means? Dienophile. File means
Like.
loving.
Like,
Okay, so it loves the double bonds. Or the two double bonds, okay? Isn't that interesting? Alright, can I erase this?
Yeah.
Alright. I'm gonna give you some examples of Diels Alder. Diels Alder is the type of reaction that was discovered about
So this is
dienes
the
and
diene.
dienophiles.
So is this picture right here, this is the diene then, correct?
That is the diene, yeah,
Okay.
and I know that picture's a little shaky because you don't see the double bond very
Yeah.
well, okay? You have to have something like this.
Oh, they do have double bonds.
It's right here.
Do you see the double bond?
There's
Oh,
Okay.
no, there's one.
It's a little shaky, but,
It's tough to see in the picture.
yeah.
Yeah, if you look at it,
Are you doing the one with our book?
solid, there's solid ones.
No, I'm doing my own version.
Okay.
Alright, so here,
It's not even on here, so.
this is butadiene.
Yep.
Butadiene, okay, and then I have propylene, okay, and what happens is, the first thing is you wanna draw an arrow here, okay, that's gonna be a new double bond, I'm sorry, that's gonna be a new single bond. This second arrow draws the pi electrons, they are becoming part of a new double bond, so this is almost like resonance, the way this is going. And then this last double bond becomes a new single bond, okay? Notice, you are pretty much drawing a six-membered ring, okay? And in that six-membered ring is a pi bond, okay? So, pretty much, you're gonna draw something like this, okay? So you're gonna find a lot of the Diels Alder, you're gonna have a six-membered ring, and you're gonna have one double bond within that ring, okay? The only question you have for yourself is, where are the substituents? That's all you have to worry about.
Where did all those double bonds like go?
Flashing through the arrows.
Okay, so can I draw in color? Would that be good?
Do it.
Okay, so that blue color shows me where the new bonds were formed, okay? And notice one of those new bonds is a double bond, okay? The other two are single bonds that help to form the ring. So this is Diels Alder. So where should I draw my substituent looking at that? Where do I want to put it? So I
Counting
want,
from the bottom of the double bond.
so I probably want to put it here, right?
Yep.
Yes.
Okay.
That's it.
Yeah, so you just have to figure out where's the substituent. All right, can I give you another one?
Cool.
Can we do the one on the like on the homework that would like for practice?
Let me do one of
That's fine.
these, and
Because I
then
can't
I'll
even
do
tell
that
like
one.
which are double bonds and which aren't, because the books is doing terrible drawing.
Okay, all right. So here is a diene, and the interesting thing with this diene is, oh, I gotta draw this better. I'm throwing in some new substituents here. Okay, you're probably not used to seeing these.
Is this true?
These are ether, okay? We haven't talked about ethers yet. Here is my diene file. Yeah, I know.
Can you explain like as basic as you can? Just explain how
Probably
you do
not.
it. Cause I looked at the tutor last night and he like lined them up in a way
Uh-huh.
where he just drew dotted lines and that
Uh-huh.
helped me a lot.
Good.
Rather than like, cause like we talked about
Yeah, I
ethers.
need that.
All right, I will do both. How's that?
Okay.
Okay, all right, here's my arrow. So the first thing I want to do is I want to draw this, then I want to draw this, and then I want to draw that, okay? And then the dotted lines would be,
So you're
Okay,
always
so
doing,
like, okay,
you're
I have a
always
question
doing
right
those
now.
arrows no matter what.
Where, that top double bond, where does that even go?
what, this one?
Yeah.
It
That
goes to
becomes
like
that.
this part in the cyclohexane.
Okay,
You should
so
get
then
models out,
on
that'll
this,
help.
like, on the addition one,
That, no wait, that does help.
where,
Have models.
where
I
is
didn't
that
make
bond
it yet.
going?
I can do it.
It's in there.
Wait a minute.
Let me show the camera.
Oh my god, I understand it.
Alright.
Good.
Okay.
This is the problem. The way
I
I drew
thought
this,
that
cat, the way I drew this is it's attached to this carbon, not this here, okay?
What's attached to the carbon?
Right here.
The bond?
Actually, no, right here. It should be right here.
Nice.
I didn't draw that very well.
lines for the substituents were
Oh, thanks. I didn't know if you were talking to her. I went.
Okay, so cat, the first thing I would draw is the cyclohexane ring.
Yeah.
I know I have a double bond right here.
Same every time.
My new bonds are these blue ones here. Now, I gotta pay attention to where my substituents are, okay? I have an OCH2CH3 here, so I wanna draw this over here.
Are you talking about the bottom one?
Hold on.
There's two of them, right? So
Yeah,
you gotta-
there's top and bottom.
I see.
Okay, so I have OCH2CH3 on either side of the diene.
So we can just assume that our product is gonna be a six-membered ring with a
Yeah.
double bond, but we just need to figure out where the substituents are
Yeah.
based on where the air.
Yeah, that's all I would do.
Does it matter? Is the double bond always gonna go like on that one side?
And then I have,
We just create-
do you see here, Ellie or Kat? This is where the single bond attaches to.
Okay.
And then attached to that is a carbonyl with, a OCH3.
Can you explain a little bit of how you place your substituents? Just like,
This is what I saw that you could do. You can number this. You could say 1, 2, 3, 4, and this is 5, 6. Okay? So notice this is at carbon number 4, this is at carbon number 1, this is at carbon number 5, and this is at carbon number 6. So you wanna pay attention to where the substituents are based on
So-
the
but
carbon
the-
number.
so they stay
But the
there?
Yeah.
other-
Oh.
Yeah.
But
Oh.
the,
Yeah.
they could be on the opposite side of it if you want.
They could,
right?
yeah, but just remember, wherever they were on the original diene or the diene file, they stay there, they don't
Oh,
go
because
anywhere.
that's on that, cause it.
So
it's
carbon,
earlier,
so carbon 5 had this, carbon 6 had this.
But it's on the
carbon-
right side of the cyclohexane.
Our book
There.
does some tricky things.
Alright, I will do one homework problem if I can.
51A preferably.
51A.
Yeah. B is just weird because one
Oh,
of the.
51A isn't that bad.
It isn't?
No. If I set it up, can you do it? And then show me
Yeah,
tomorrow?
Yeah.
just draw the I don't know how to
You don't
attach
actually
it,
move
what
them.
what
You just
works as a
move them.
substituent.
Yeah,
That's what I don't get.
That's all.
Is this 51A or B?
A.
This is 51.
This is 51.
Yeah.
I hope they heard that.
Feel bad for him?
Everyone who's back here, I just had such a moment, like,
See,
of
I thought that
understanding.
the lines for the substituents were part of the carbon chain, and that's why I was so confused.
And now I know, like.
Wait.
Okay,
where-
so that's
That,
how,
those two on the ends aren't carbons. Those are hydrogens.
are they hydrogen?
Yeah.
So you're saying OH?
No, on the other one, the first problem.
These are hydrogen?
Yeah.
Alright,
Wait, is this 51A?
so the diene is here, the diene file is there.
Yeah.
Okay, so this becomes a single bond, this becomes a double bond, and this becomes a
You show the
It
arrows?
still makes the same. So, would it just be this then?
Hold on, I'm trying to draw I didn't draw this very well.
Can I draw this last one?
No, wait, that's what he did too. He, like,
Yeah.
like-
Yeah,
It's just so low.
that's alright.
Oh, girl, you're so tall though.
Now, I didn't get to Alkynes like I wanted to today, okay? So
That's okay, we made a breakthrough today.
You made a
so
breakthrough.
I think we're.
okay.
So this
I think we're doing just well. I still have 3 so that's.
Yeah, that looks good, Austin, actually. Yeah, then you want the mirror image on the other side.
Okay,
Yep.
is Austin drawing the product?
Yes, he is.
Okay.
We need an accent, that's
smart.
right.
Girl, I can't
Oh,
see.
here, right?
Yeah.
Here and then there, something like that.
Yeah, okay. Alright,
Okay, so since there's already a double bond on the top
So it's this.
and there's like a carbon, where does it go?
wait, you gotta show me which one you're talking about.
It's like usually here.
Let's skirt.
This one would go to where this is.
So, this hydrogen, I didn't draw it very well. So this carbon bonds with that carbon.
Oh,
This
is just
carbon,
substitution.
yeah,
this,
yeah,
that's
this is
Yeah.
substitution. This
Oh.
bonds
We're all
with that
finished
carbon.
now.
Okay, so
Okay,
like,
so this is here, this.
I do 55.
It's a carbon combination car.
okay, I'm not.
Okay.
So it is add
I'm not
All right.
describing them.
Will you
Hey,
write me a
Jamie,
note?
could you hit the button on my
Yeah.
phone for me? Thank you so much.
Will you write